This is Lokesh from EC department from B section. I'm going to speak about folded dipole antenna need and advantages, which is done by me. First of all, what is folded dipole antenna? It is the variation of standard dipole antenna, which the conductor is folded back and connected at the both of the ends to form a closed loop. It is saying that when all the loop in the antenna is closed parallelly with the parallel wires, it is called as folded dipole antenna. When coming to next slide, we get the designs basic where we get lambda by 2, which is wavelength. It consists of two parallel elements. One is lambda by 2, which is wavelength, and the other split the point for the input and output signal, which the wavelength is splitted by the two signals, which is input and output. The diagram diagrams shows a folded dipole connected via 4:1 transformer to match the higher impedance to coax cable. Here the coax cable denotes that the where the main or maximum radiation or the maximum impedance is there will be a maximum current to the receiver side. So it is better to have the coaxial cable in the transformer side. When coming to next page, we get the pictures of folded antenna dipole. In this, there are two loops connected in one such antenna where there will be a maximum radiation or directivity in the receiver side to transformer side. And then when coming to next point, why we need folded dipole antenna? Where there is the folded dipole antenna in the world, why do we need it? It gives input impedance as higher, and it is performs very better impedance matching when needed, used as a driven element in antenna arrays. Antenna arrays means it is kept in the parallel sides, which uses to drive the element. It bandwidth is higher and improved. We can improve the bandwidth of the given antenna. And coming to next slide, we get the advantages, which is key advantages. The first key advantages is higher impedance matches with balanced lines like twinlet. The twinlet is represented as parallel lines in the antenna, and then wider bandwidth than a simple dipole, ideal for TV and or FM reception. Better mechanism strength from the double conductors. This stir point teaches that when there is only one conductor, we get an minimum voltage or an current. While keeping an two or parallel antennas, we get the maximum radiation or the um, maximum radiation for the receiver side. It is simple construction where it is very simple to construct and it is very cost in less. Here one more key advantages, which is larger physical size, more complex construction, higher in costs, and impedance may not match coaxial directly. It is like not connect directly but connect with the extra quantity or external devices. Limited power handling. In the thin wire designs, only limited power is handled while communication from transmitter to receiver side. When coming to applications, the applications are in television receiving antennas and FM broadcast reception. First of all, a fold dipole antenna consists of two parallel conductors connected at the both ends. It is similarly to a half-wave dipole, but its impedance is higher, usually around 30 ohms. So first coming to television broadcasting, one of the most common application of folded dipole in the TV antennas, and it is widely used in the VHF television broadcasting, which is wider bandwidth, improved signal reception, and better impedance matching. And also when coming to FM radio antennas, folded dipole antennas are common in FM radio receiver and transmitters. It provides stable performance, good signal strength from the transmitter to receiver side, and it is less power loss. And this is the application picture or images of the folded dipole antenna or the array antenna, which is connected in the parallel side to get the maximum radiation for the receivers. And then finally, I kept the impedance formula because to calculate the impedance of the antenna is very important to with the diameter, which the formula is Z is equal to 4 into Z dipole. Dipole means here and conductor with two sides, 4 into Z, which is 4 into 4 sides into impedance. And then when coming to half wave dipole is equal to 73 ohm. When coming to the impedance of free space is 733, and when we multiply 4 into 73 we get 300 ohms in the half wave dipole. If conductor diameters are different, impedance depends on the ratio. It explains that if the conductor diameter or the length of the diameter is differs, the impedance of the folded antenna will be differs. And then the picture of the fold dipole antenna is this, where we get an dipole folded in the one side, which is like a coaxial cable. And then when coming to last, we thank you that for listening to me. Thank you.